Thank you. Sorry for the technical difficulties. Welcome to my presentation. My name is Sami Uddin, and I'm here to present our work on HandMark menus, a rapid command selection, a technique for rapid command selection and large command sets on multi-touch displays. And my co-authors are Carl Gutwin and Benjamin Lafreniere. So in this presentation, I'm going to show how hands can be used as powerful landmarks in large tabletops for fast command selection. Okay, landmarks. So landmarks are basically easy to remember iconic places. So they help us to develop spatial memory about their surroundings. So we can easily remember different objects and places with reference to landmarks. So different graphical user interfaces have leveraged the concept of landmarks to develop spatial memory of certain commands. So they help us to remember those commands and revisit those commands quickly. Take this image as an example. So when we want to close an open window, we always know where to look for that cross button. So based on the operating system, it would be either on right side or left side on the corner. Yeah. So here, corners of the screen are landmarks that help us to remember commands location. So there are some other techniques which also have leveraged these spatial memory techniques of landmarks for fast command selection. Fast tap menu technique for tablets is a good example of it. So fast tap uses spatially stable grid to place commands. So here, corners and grids are working as landmarks. So they help users to remember commands locations. So once the locations are learned, users can use landmarks and spatial memory to access those commands quickly. However, that technique is not feasible for large tabletops. So large tabletops mean less number of landmarks. So corners are still there, but what about the commands placed at the middle and edges of the screen? So fewer landmarks in tabletops make it really hard for the user to remember the commands. But for any kinds of tabletop interactions, so one tool is always common, that is our hands. So hands and fingers are very powerful natural tools, so that are always available in all touch-based interfaces. So we carry them with us all the time, and we are very much familiar with our own hands and fingers. So we know their shapes, sizes, and positions accurately. So we can even touch a particular finger of one hand with another hand without even closing our eyes, because we know them very accurately. Yeah. So why not we use the all-time present natural artifacts, hands and fingers, as landmarks for better tabletop interaction? To use hands as landmarks on tabletops, so we have created a new technique called HandMark. So it helps the users to learn commands location by using the proprioceptive knowledge of their own hands and fingers. So as commands are placed around and between the places of fingers, so users can remember commands locations with reference to them. So we tried in different ways and came up with two versions of HandMark techniques. So first one is HandMark-Finger, you can see in the left side. So it's for relatively small command sets. And another one is HandMark-Multi, so it's in the right side. So that supports a relatively large command sets. So details are provided in the paper. Here I'm going to give you a high-level overview of our techniques. Okay. So HandMark-Fingers. HandMark-Fingers is a basically bimanual technique. Naturally, the commands are hidden from the users. So this technique requires one hand to invoke the command sets and another hand to select the commands. So it provides modal access to two sets of commands. Each belongs to one hand. So as you can see in the video, we placed commands around and between the fingers of both hands. A single set has 21 commands. So by combining two hands, so it can support 42 commands. So this technique can be used in two ways. At the beginning, when users are at the novice stages, so they can complete one task by following three simple steps. First, they can invoke a set of command by placing all the 5 fingers of one hand and keeping some spaces between the fingers, and then search visually for a desired command, and finally execute the command selection with another hand. Here you can see, yeah. And once the locations are learned, users become expert. And as you can see in the video, expert users can combine menu invocation and command selection into single step to make the process faster. Here you can see. Okay. Now the second version, HandMark-Multi. So similar to the previous HandMark-Finger, HandMark-Multi also a bimanual technique. It provides modal access to different command sets. So the main difference between HandMark-Finger and Multi are in their commands placement and their menu invocation technique. In HandMark-Multi, we placed a set of 20 commands in a spatially stable grid between the space of thumb and index. So there are 8 sets of commands, and 4 sets belong to each hand. So in total, it supports 160 commands. So as you can see in the video, different command sets are mapped to different number of fingers, and for 8 sets, there are 8 finger combinations. So the technique requires specific number of fingers along with index and thumb from one hand in L-shaped posture to access a particular set. Same as HandMark-Finger, in this technique, novice users can complete one task by following the similar 3 steps. However, once the users become expert, they can combine menu invocation with specific number of fingers and command selection into a single step. You can see there. Okay. To evaluate the performance of our new techniques, so we conducted experiments. So in one part of our experiment, we compared our HandMark-Finger with standard tab-based menu system. Tabs 2 had only 2 sets of command, 2 tabs to match the HandMark-Finger. In another part, we compared our HandMark-Multi menu with similar standard tab-based menu system. We are calling it tab 8. But this time, there are 8 tabs in the system. So for both of the standard tab menus, we placed command at the top edge of the screen, and commands were grouped by colors and types so that they can be easily recognized. The participants could tap on the tab head to access one particular command set. So 8 targets were used in the experiment, and they were appeared in random order before the participants, and you can see the location here for both of the techniques. And we have used only 8 targets in the experiment so that participants could easily familiarize with them. So we have analyzed the data from the experiments, and we found some interesting results. So first, I'm going to show you the results between HandMark-Finger and tabs 2. So in case of selection time between HandMark-Finger and tabs 2, so if we look at the graph, so we can easily see that HandMark-Finger performed better throughout the time, and it was highly significant. So at the beginning, participants had no idea about the command's location, so they had to search visually between the 2 sets to find a particular command, and that's why they took more time to select command in the earlier stages. However, this graph also shows us that once the participants learned command's locations with reference to hands and finger, they started to perform fast. So we further analyzed error and wrong set selection rate in our experiment. So in our experiment, error means the incorrect command selection. So consider the chart at the left. So we can see that errors were low for both HandMark-Finger and tabs 2. So we have also analyzed the wrong set selection. So it means the number of sets opened to search a command. So if you can see the chart at the right, so we found that wrong set selection was low for both versions, and they are not that much significant. So these results indicate that participants were using hands and fingers successfully to remember command's location. So we collected participants' preference after the experiment and found that they preferred HandMark-Finger by a large margin. Then overall, 12 out of 13 participants preferred our new HandMark-Finger technique over the standard tab-based menu. So now I'm going to discuss about the results between HandMark-Multi and tabs 8 system. So if we consider the graph of selection time between HandMark-Multi and tabs 8, we see that overall tabs 8 performed better between the two techniques. And in the early stages, as the commands locations were totally unknown to the participants, both versions were slow. However, from the graphs, it's also evident that at later stages, after learning the commands location, HandMark-Multi also started to perform at equal rate with the tabs 8. To analyze this thing further, so we looked at the errors and wrong set selection. So in case of errors, so as you can see in the chart at the left, so HandMark-Multi had slightly higher error rate than tabs 8. And if we look at the right side chart, and we can see that wrong set selection was significantly higher for HandMark-Multi. So let me assure you that wrong set selection was not the count of errors. So actually, it was the number of sets that were traversed by the participants in order to find a target command. The reason lies in their menu invocation method of the two techniques. So if you can see in the image at the top of the standard tabs, so there are 8 sets of commands, and they were clearly labeled with their names. So participants could easily use those names to select the tabs. So however, in case of HandMark-Multi, 8 command sets were mapped with 8 different fingers, 8 different finger combinations, and they are not visually indicated to participants. So here, in this image at the bottom, so you can see there are 4 different finger combinations for the 4 sets that are mapped to the left hand. So there are another 4 with right hands. So we believe, so this was the main reason which made the difference in errors and selection time between two techniques. Though errors were slightly high, most participants preferred our new HandMark-Multi techniques over the standard one. And overall, 10 out of 13 participants preferred the new HandMark-Multi technique. So in the experiment, our main goal was to see whether the participants were using their hands as landmark or not. And during the experiment, we observed that all the users were moving their hands, were moving their menu hand selection finger. Sorry, let me rephrase it again. So all the users moved their selection finger toward the correct region on the menu hand, even before the menu hand was placed. So these preparatory actions were a clear indication that participants were using hands as landmarks to remember the commands location. So as a summary of the results, I can say that hands were being used as landmarks to remember commands location, and our new technique accommodated large number of commands. HandMark-Fingers performed faster than standard tabs in all stages, but HandMark-Multi was slow in early stages. However, they performed equally once the locations were learned. And finally, most participants preferred our new HandMark menus. There are some limitations in our experiments, so we will try to overcome those limitations in future. So let me give you some example here. So in case of HandMark-Finger, participants were required to use all the 5 fingers of one hand to invoke the command set. So it was relatively easy for them to place all the 5 fingers of one hand on the screen. But in case of HandMark-Multi technique, specific combinations of fingers were required to access a particular command set. And within a short amount of time, it was really hard for the participants to make specific posture with different fingers. So it requires further research to make the process more ergonomic. Currently, our prototypes support only one user from one fixed location and orientation. However, after invoking a command set, it was possible to move and rotate command sets into any direction to overcome any occlusion. Further work is required to allow multiple users from different orientations of hand. We also found that HandMark-Multi did not provide any visual mapping indications between fingers and command sets. Participants had to go through different sets by pressing down different fingers combinations. We also saw that HandMark-Multi performed slow because of this reason. So different colored legends attached with different fingers might be helpful to map fingers with command sets. So we would like to see in future how mapping of commands affect in selection time and wrong set selection for HandMark-Multi. So finally, what I want you to take away from this presentation is that hands can be used as powerful landmarks in large tabletops for fast command selection. Thank you, and I'm happy to take your questions.
And I will get someone to bring a microphone to you.
Hi, Richard Miller, Oracle. I'm curious how much you thought about the type of gestures that maybe you could have done to improve the time on task. So, you know, you did this kind of two-handed thing, which to me I kind of cringed. It seemed pretty awkward. And I'm wondering whether you thought about like a one-handed gesture. And also maybe you could comment on sort of your relationship between this and sort of basic information theory. And that's a lot to remember. You know, the whole 7 plus minus 2 now is referred to as 4 plus and minus 1. So it seemed like a lot for me to do versus the other task, which obviously you could just, you know, recognition versus recall. Thanks.
Okay. So in case of HandMark-Finger, actually, so we used actually 2 hands, and we used the spaces between the hands. So it was really hard for the people to remember the commands at first. We thought that. But from the experiment, we found out that people are easily remembered the positions, and they preferred this technique. So I think it's possible to remember the commands. And that's what we're trying to see in this experiment. And later on, we extended our experiment to see whether people can remember multiple commands or not. That's why we tried the HandMark-Multi system. So we multiplexed the commands, and we have used different finger combinations there. And from that experiment, we also found out that people are able to remember those commands. And yeah, it is also another point to be noted that in HandMark-Multi, there are 160 commands. And people actually don't use all the commands at a time. So they use specific sets of commands. So like the save, control, save, cut, copy, paste, this kind of commands. So we can easily use this icon as a shortcut icon or hotkey icon. Like you can see in the HandMark-Finger. So we place some icons on top of the fingers. So those can be used as shortcut keys. And for HandMark-Multi, so from our experiment, we found out that the commands placed near to the fingers, like index and the thumb, so those are easily accessible, and people are accurately remember those positions. So if we can place the commonly used commands on those positions, so we believe that it's possible for them to remember. Yeah.
Yeah, is this on?
Okay.
Yeah. Hi, I'm Joanna Bergström-Lehtovirta. Like this? Yeah. Hi, I'm Joanna Bergström-Lehtovirta from University of Copenhagen. I'm interested on how you mapped the targets to, especially in the finger case, and so how do you design the positions of the target? So now there is about 2 between the fingers and then 1 in top of the finger for each fingers, versus to the other condition. And how do you think if there would be, for instance, more targets in top of the fingers or less or more between the fingers, how would that affect the target selection time? Okay,
that's a really good question, and we talked really during the course of this work. For placing the commands, actually we have considered the size of adult finger size. So from previous experiments, it is found that normally the human finger size is around 16 to 19 millimeters, and the targets that can be easily accessible by the users is around 7.9 millimeters. So we considered those parameters to place the commands actually, and